Hello everyone, my name is Dimitri and I'm the developer of Nodus text network analysis and visualization app. In this video I'm going to show you how you can use text network analysis to analyze and visualize any scientific discourse so that you get something like this, that when you analyze a certain topic in science you would be able to have a visual overview of what this topic is about, what are the main concepts inside, how they're related, and what could be the new interesting ideas that you could contribute to this particular scientific discourse. So in order to make it work, you need to log in Nodus and choose the scientific import app here, scientific papers titles. And first you type in the search terms you're interested in. So for example, in this case, it's text network analysis. We will use Core AC UK database as the source, which is the world's largest collection of open access research papers. Leave all the rest of the settings default. And then we click import here. And what will happen next is that Nodus will extract all the scientific papers that are related to those search terms, text network analysis, from the database of Core AC UK and visualize them as a graph, where the words are the nodes and the co-occurrences of the words are the connections between them. Like this, you can see the graph of the main topics and of the relations between them. It will use the titles of the papers and their abstracts as well. So you will have quite a detailed overview. If you want to have a more general one, then you could also select just the titles without the abstracts. Maybe for a first iteration, it could be also useful. So here we have the visualization of the topics for text network analysis. And if we zoom in, we will see that here are the main topics that are related to those terms. For example, recognition, image recognition, detection. Then we have semantic models here. Then we have something about neural networks as well, and so on. So you can use the graph to explore the discourse around these three terms. By the way, they are also here. If you click on them, you will get them back into the graph. And as you can see, then they will overtake the rest of the discourse. So this is why by default we actually remove them from here. And you can also do it with stuff that seem to be quite general. So you just select the nodes and delete them from the graph to see what are the main topics hiding behind them. So here we selected and removed from the graph text network analysis, and then we see the context in which those terms appear. You have the analytics panel here that shows you the main topics. So for example, the main one is propose, detection, base. If we click on those terms, we can see in which context or in which paper those terms are used, and there is also a link to this paper. So for example, here there's quite an important one which is talking about detection mechanism, comments, detection. So let's click on this paper, and then if you click on the link, you will actually be able to see the paper itself and see in which context those terms were used in that particular paper. You can also select other topics, and then the system will filter the research papers that have the highest concentration of those terms here. So for example, semantic model representation here. We have a few papers here that relate to this topic and so on. So then this kind of analysis gives you a very good general overview of what is the discourse around a certain subject. Okay? The next step that you can do is to actually go into the Insight tab that will help you generate new ideas. And what it does is that it looks into the structure of the network, and then it identifies the two topics that are connected but not so well, that could be connected better. And it proposes you a research question that would link those two topics together. This idea is derived from social sciences, where you can identify a structural gap between two groups in order to see which clusters you could connect to generate innovative and interesting ideas. And here we just apply the same metaphor into text networks, into discourse networks. We look at the graph, we look at the two topics that are quite prominent inside the graph, and then we propose that they could be connected. And maybe this is how you could generate a new idea. So for example, here you have semantic model representation and data study research. So if you click on those two, actually you can go to statements to link tab, and then it's going to show you, okay, all the statements, and then again statements to link. Then it's going to show you here what are the two papers that you could actually connect. Okay, so it's here, statements to link. One is a network text analysis of Fight Club, okay? And another one is semantic relevance-based neural network for text summarization and simplification. So we could read those two papers and maybe think how they could be connected. If there is any interesting way or research question that could connect the ideas that are expressed in those two papers, and hopefully it would help us generate a new idea. If, let's say, you think that this is not an interesting connection, for example, the words like data, study, research is something a bit generic, you can select them, delete them from the graph, and then Infranodus will recommend you a new possible connection. So two more papers that could be connected together with an interesting idea here. So if you go to filter and then statements to link, you would be able to see these two papers. And then you have the links here that can show you those two particular papers, so you would be able to see. And here in this case is text coherence analysis based on deep neural network. And then another paper is extraction method of ITSS common skill knowledge using Japanese text network analysis. Okay, so this is two papers that we could link together to generate new ideas. And I invite you to use this graph in this iterative manner, this way, you know, just looking at the main terms, removing them from the graph, seeing what's hiding behind them, looking into the inside panel, and it becomes like a very interesting game that you can play with yourself to discover a certain subject on the one side, to get an overview of it, of the main topics inside, and also to see how you could generate new ideas by bridging the structural gaps between different research paper and topics inside. One more thing, if this graph seems to be a little bit overwhelming, and for example, you would like to have something a bit more readable at the beginning, let's say with less terms, if you go to the import app here, I'll show you, you can do the same search, text network analysis, but this time exclude the abstracts. So just adding the titles of the papers only. And we save it into a new graph, visualize it, and now what will happen is that Infranodus will only import the titles of the papers, not the actual abstracts. And this will make the graph less dense, and you will be able to see a little bit better what are the main hot topics at the moment, right? So here it opens already automatically on the structural gap, because this was the last paper we saw. But you can just go to the filter and see all the statements first. And then we see that, okay, so if we just analyze the titles of the papers for text network analysis, there is a lot about neural networks. So we know it's a hot topic in text network analysis, neural networks. And then I guess base is based because this word is used quite a lot when you write a title, a method based on something. So we can even delete this and see what's hiding behind it. Okay, so we have social mining. So mining something about social networks, so from social networks. And then also there's quite a lot about, let's say, neural architecture. Let's click on this, see in which context it's used, and so on. So you see, you can actually, again, use the graph in this iterative way to be able to see what are the main topics, how they're connected, and what are the hot topics at the moment. And this graph is much less dense than the one that we had before. So if you want to start with this, maybe it's good to use it without the abstract first, and then add the abstracts after. So here's how it works. Try it out on infranodus.com and let me know your feedback. I hope you enjoy using the app, and I'll put a link in the description to the help article that explains how to use Infranodus in more detail. Thank you very much.